So aviation lighting 101 is kind of what we're going through today. Um, we'll kind of run through just some background stuff based on basically who we are, who I am, that kind of stuff. Go into what lights are out there, what different types of lighting sources, what do you need to know about them, just the differences, what do you need on an aircraft, what's required, those are the important things. If you're an upgrade, what's it take to do those upgrades? And finally, got to put that in the logbook at some point. How do you go through and do that? And then I want to spend the last little bit for kind of a Q&A. Any type of questions, any of those things we'll kind of walk through. So I'm at Whelen Aerospace Technologies. Whelen is a legacy OEM lighting supplier. We were founded in 1952. Founder George Whelen III invented the rotating tube. Put on his own airplane, didn't want people to rent him, and put it out of the garage in Connecticut. The next year he said, I bet you that rotating beacon will work out the police car. And so we went on to the police car. 73 years later, Whelen Aerospace, we have about 85% of the vehicle market for external lighting. So you're seeing lights that are generally a Whelen product from the past. We are about 55% police vehicles in the world are our lights, and 85 to 90% of all vehicles are fire trucks. So automotive is gigantic. Aviation, where we started, it's still a very big company. We're a big guy in the industry, but we're the big guys that children. So that's kind of the fun part for that. We also have a company that is huge in the Whelen family called AeroLEDs. AeroLEDs came about in 2006. Started making AeroLEDs came in and started making LED bulbs 2 years ago. And came in with a significant amount of focus in the They did a great job. What are the other options with the front lights? Have a pulse, the light mechanism itself, and things like that. Last year, Oshkosh actually was going to be announced that bought part here. These now we're one big happy family. We've kind of gone through. We've got some overlaps in products, but we've also got some things that are very complementary, and we're working on some of those items. So, sources of light. 4 main sources we see in aviation. We've got the incandescent lights, which are kind of the old standards. The halogens, which were an upgrade, got a little better output out of them. They're a little hotter. Then we've got the strobe, which are the ones you used to see that haven't kind of seen on film too. Or we've got the LEDs. They all have great advantages. They all have disadvantages. The incandescent stuff, very little support left for them. The filaments are always very fragile. They don't last very long. They're not very, we'll say, repeatable. One of the reasons for that, what we see in an old standard GE style bulb on an aircraft, it works perfect the first time you turn it on. If there's a filament in there, it's always for some reason horizontal. So that filament is always bouncing as you're taxiing or moving. But the first time you turn it on, it gets hot, it expands, and then it doesn't quite contract at the same level. It does it next time, every time it starts to improve. The further it droops out of the middle of the reflector, the worse the outcome. It's to the point where you're so far, it breaks. So you go through those, you're a 25-hour kind of replacement. There's no warranty you see on those. They're very hot. They're not very efficient with it. And as I said, they're pretty short lifespan. Strobes. First thing I would say at strobes, be careful. There's big capacitors in these power supplies. They'll hurt you. They'll hurt you. You won't forget much of those. So anytime you use those or move them or operate with them, there is a procedure to discharge that capacitor. Please follow. Even if it was on an hour ago, there might be enough charge there to close it. So typical strobe. There's a tube filled with xenon gas and a wire wrapped around it. And we use this transformer and send out 700 volts in a quick impulse, and it's enough of a neon light to make it work. So that's why we have so much voltage that comes out. They work well. I'll guarantee you that there's power supplies in the market out in airplanes right now that have a date of 1962. They're put on the airplane, they don't work. They're very expensive. Is it? Okay. I can kick up. The strobes all require a power supply. So the power supply is either self-contained, like on a beacon, or it's a remote one, and then you have the wires that run out to the strobe. And as I said, a huge amount of electricity is sitting in there. LEDs, like mid diodes. Few characteristics. Very low power. That's what we want. We like that when we turn them on, we need it on. It's not a ramp up far out to come on. It's immediate on, immediate off. Weigh a lot less, last a lot longer. There's no filaments to break, and the LED technology improves about every 7 to 8 years. When I say that's a new generation, what I mean is for the same amount of current that you would put into an LED, you get generally twice the output for that same amount of current. That allows you to get lower and lower current draws as you go on, or brighter and brighter lights. Few different considerations we keep in mind when we design lights. So one of the things are designs are not equal. Thermal management is probably the most important thing about LEDs. The misconception is that LEDs don't have any heat at all. It's actually the opposite. LEDs have a lot of heat, except they don't create infrared heat, which is what our standard bulb does, which you can feel at a distance in your hand. There's a lot of heat on the unit itself. The warmer that unit gets, the more close to the critical temperatures that all the components around there have. And most of the designs have a mechanism so that once they get too hot, they start to reduce their output to save the circuit, essentially. That's something that is common to every LED, every manufacturer. They're going to start at a certain output, and they get really hot. They're going to start protecting themselves as they go down. So thermal management is a very, very, very important part of the LEDs. Serviceability is also a big one. If I break a lens, can I replace it? If I'm going to take this aircraft and try to make it a replacement, how difficult is it going to be to install? Those are things that you don't really think about, but they come up a lot. Compliance with federal regulations. I'm going to go into that a little bit later, but that's a very important thing. What does comply? What doesn't comply? How do they say that it did comply? Those are some items we always look at. And recurring maintenance requirements. You install a part on an aircraft, it's always important to look at the installation guide. There's always a section that says continuing airworthiness. What does it take to keep this thing airworthy once it goes out? Some are very simple. Kind of the old Ron field set, forget it. It's gone. Some take a lot of maintenance after the fact. And if you don't comply with that maintenance, you technically don't have a compliant installation. So a couple different configurations. Gearing obviously on LEDs, that's where everybody's looking at with everything. So we have a self-contained. This is most of our units. These would be wingtip lights or beacons where everything is in there. These are flush mount. There's nothing behind them. They mount right to the aircraft. 2 wires, 3 wires, 4 wires, depending on the installation. Everything's there. It's a self-contained light. That's most modern LED solutions. We also have a remote where we have a remote flasher that may still put some extra power into the unit. Maybe we had to cool it. Generally, that's an older generation. That would look something like this, where we have a power supply separate from the strobe. This comes off the Cessna restarters. Cessna still have the strobes out. We also have an LRU. These are the, say, sexy-looking lights. These are the ones that you find on business jets and things like that a lot, where you replace an entire unit in and out. Generally, it's like a larger aircraft. And then one of the most important things is that the base, the mounting area we use, we try to mimic the original. Many reasons, simplicity is one of them. You don't have to repaint the aircraft, you don't have to do all that, but most of these lights had something specific for what is the installation location. How do we have the holes mounted? They're all slightly different, but they were all very clear. So we try to match up the best we can. So some things with LEDs. LED assemblies are awesome because they don't really have any issues with vibration. There's not anything to move in there. So they do very well on helicopters or things that are out of balance and not perfectly kind of run, but they work really well. Like I said, the output, both color and the intensity, stays very constant for a long period of time, unlike the other halogens and things that burn out very quickly. The condition of the lens is important. The thermal stuff is important to LEDs. The condition of the lens is also a very, very important item. I'll go into that a little bit later as well, but that's an extremely overlooked portion of lighting installations. Are the flashing circuits integrated, or do you have to have extra stuff that's remote? What's the weight going to be to add all those things? And retrofits sometimes is not always directly possible. You might need OEM intervention, which generally means an STC or do something along those lines to kind of weigh that through. So when we look at the requirements, there's generally three things we use. First one is the type certificate. What was the aircraft originally released with? What lights are on the aircraft? The OEM will also specify in the kinds of operation, these are the lights required for each build. So that might be more restrictive than the regulations. So the OEM is where we look for one of those, the type certificate. The second one is your type of operation. Are you a Part 91 aircraft? Are you doing charter? Are you doing things like that? They all vary. We're going to focus on Part 91 today. But then we also look at, okay, are we day? Are we night? Are we IFR? VFR? Are we carrying passengers for hire? All those that include flight instruction. That's for hire as well. The last one will be the type of operating procedure. Do you have off specs that you're operating under? Do you have an MEL? And your minimum equipment list requires something different. Not very common generally in a Part 91, especially smaller aircraft, but it's something we look at. The one that I think is most important for us to talk about is the type of operation. So, what do you need to operate an aircraft? Return to the regs, Part 91, and look at 91205 and 91209. 91205 is your minimum equipment required for flight. Day VFR says we need to have a strobe light for anybody who's had an aircraft type certificated after 1996. So technically most aircraft out there don't require any lights during the day. Night VFR, we've got approved position lights, approved anti-collision lights if the aircraft was built after 1971. And by built, I mean type certificated. So even though you might have a 2005 Cessna 172, the type certificate was from the 50s. That goes all the way back to the old. It doesn't have to follow this. In yellow, I put here, if the aircraft is operated for hire, one electric landing light. Technically, you don't need a landing light to fly. Would you want to do it? Of course not. But technically, you don't need it. So it's only if it's for hire. We get to 91209. This is the sunset to sunrise, Alaska, 6 degrees below the horizon. Nobody can operate an aircraft unless it has lighted position lights. Red light must have lighted position lights no matter what. And if you have an anti-collision light system, it must be operating. Except the anti-collision lights need not be lighted when the pilot in command determines that because of operating conditions, it would be in the interest of safety to turn the lights off. When would we do that? Taxi on the ground, snow, rain, those things. Notice there's nothing in here that says you can turn your position lights on, right? So position lights have to be on, steady, on. We'll get to that a little bit, but can't flash them. So we also have this little word here, approved position lights, approved red or white anti-collision light system. What does approved mean? Well, FAR 1.1 in definitions, that the FAA or their delegate, somebody they say can also approve, has approved something. Meaning, there's an action that has to be taken by the FAA to say this is an approved system. That could be a TSO, PMA, STC, it could be an OEM saying, I built all these lights, here's all my proof, all my data. Those are approvals. The other one says, for any person to whom the FAA has delegated its authority. What was that? Is that just you with the pilot taking doing Part 43 preventative maintenance? No. It's who is the FAA trusted for that type of data. What we end up finding in aviation is the lighting, that's SAE, Society of Automobile Engineers. No, it doesn't make sense. But yes, that's who governs aviation lighting. That has been somebody that comes to you to say, okay, you're already doing lighting, you have a very good specification on this. We don't have the engineers that are just lighting people. SAE can also write some guidelines that we use. Now, some of you might have noticed something here. 91205 says, except as provided, no person may operate a powered civil aircraft with a standard U.S. airworthiness certificate. Who's got an experimental or a light sport? Something other than a normal category aircraft. Does this apply to you? The answer is yes. I am leading the witness here. So, difference, standard versus special, specialty light sport, experimental, special flight permits. Every special airworthiness certificate is issued with operating limitations. You receive your airworthiness certificate. It has the ticket at the top, and it's got conditions. Every single one of those will specify the AVFR, if operated at night, must comply with 91205 for lighting. So even though you're in those categories, your operating limitations of your certificate of your aircraft require at night you comply with that. Now, why is that? Anybody have an idea? That's why we all went experimental as light sport, right? The reason for it is the FAA looked at it and said, who are the physician or anti-collision lights helping? Is it the person flying the airplane? It's another guy, right? It's to help make sure somebody isn't coming, not seeing you. So it's a standard across. You must have an approved system. So that's a big difference when it comes, if you're flying at night. During the day, it's okay. FAA always comes back to several different letters. This is an interpretation from FAA Legal. For somebody who asked, do I need to operate lights at night? I'm on an experimental ticket. And it says, we direct you to 91.9, which requires any person operating a civil aircraft to comply with the aircraft's operating limitations. It says, the policy kind of goes through, specifically addresses your reference to 91205. Under the policy, it says, after completion of phase 1 of flight testing, aircraft appropriately equipped for night and or instrument flight in accordance with 91205. Meaning, every single one says you have to have it. So even though you're an experimental, you're going to fly at night, it has to be a certified system. Reiterate what's needed at night. Position lights, anti-collision lights. The color and intensity can be determined depending on the operation of the aircraft. And a landing light if you're operating for hire. So here's how we define these requirements. We have regulations. Every aircraft certification is going to say, I need this, I don't need this. These are what you need. Is it a helicopter? Is it a large aircraft, small aircraft? Each one of those items. The other one is a TSO. So TSO is a validation of the performance of the lighting. It's a performance requirement. So we have two TSOs that govern aircraft lighting. TSO C30, that's position lighting. There are 3 types depending upon we have requirements for red, for white, and for green. We have TSO C96, that's for strobes. C96 has 3 classes. Class 1 is helicopter. That's for helicopters made after about 1965, type certificate after 1965. Type 2, and class 1 is only red. Type 2 or class 2, excuse me, is the brightest. Doesn't make sense that it's the brightest and it's the middle. However, this would be for all large aircraft and for any aircraft that are fixed wing aircraft that is a type certificate after 1971. So this is most newer aircraft comply with this. Whenever we can, we said go grade, go home. Like make sure you get the brightest you can so you can get home. Nobody can see it. In any event, we always try to go up. There's usually slim, no cloud difference to go up to the higher class. Class 3 is anything with an older type certificate. They can be white or they can be red. They can be split half and half. It's a lower intensity. So we have these little things, effective candela, and that determines the output of each of those lights. Effective candela is a formula, I won't go into the depths of it, but it's basically we have a really bright flash, then an off time, and a really light flash. What we do is we take the start of the first flash to the start of the next flash, average the intensity. So that's how bright it is to see what we do. So position anti-collision lights. I'm not going to go through all this stuff. The biggest thing is position lights. We go from 0 degrees to 110, 0 to 110, cover the tail end with white. Those have to be visible inside the aircraft, all the way up to the north and south poles. The goal there is we want to be able to reference where an aircraft's moving. White, red, and green, same as the boat. Anybody understand how that works when compared to aircraft right of way? If an aircraft is flying, the left wing is what color? Red, right? If you see red, that aircraft, you're looking at the left wing. So if you look at it, that means the aircraft is like this, which means it's on our right, with the yield to the right. That means red, stop. You gotta go by that. Opposite side, right wing's green. It's coming this way, and you see green. Green means go. You have the right of way there. It may not be safe, but it means you have the right of way. That's why the red and green are in that color. Intensities for anti-collision lights. There's a couple different zones here. So old anti-collision lights, the class 3, only need to go 30 degrees up and 30 degrees down, up to the sides. The newer ones, everything after 1996, has to go up all the way to 75 degrees up and down. Reason being, as aircraft got faster, they wanted to have more coverage because aircraft can climb and descend faster. So it's a good way to cover all of those, which is why they wanted a higher output. Helicopters are the same thing. The difference is helicopter strokes generally are red. Same position light requirements. The anti-collision requirements only go to 30 degrees. Rationale for helicopters, we went up to 75 with the rotor. You get elevation, you can see it in the cockpit. They're kind of flashing. The one thing to note with the position light, we understand that it's going to be out in the wings. So when we do, for example, our tests, our lights, we don't go from 0 to 110. We go from -10 to about 120, so that we have a little bit of overlap. Because you want that aircraft lights to convert at some point in front of it. So we do that specifically so that we have that coverage. The FAA gives you actually 1,000 feet. Way too much. But it is what it is. Generally speaking, most manufacturers have some lead that goes there on purpose. It's very unique though because we have this intensity that be a minimum all the way around the sides. When we get to those overlaps, we dive down under a max. So we might be 110 gallon output. Then we have to be under 5 under those requirements. So that takes a lot of work to get that to go through, but that's also part of the TSO. We're exploring that. Now we get the fun one. Landing taxi recognitions. There's no standards. There's none. In fact, we technically, as I said, don't necessarily need to have them even when you're there. The recommendations are there. SAE issues those. SAE issues AS standards, aerospace standards, for position and anti-collision lights. For landing taxi recognition lights, they have ARP, Aviation Required Recommended Performance. It's a recommendation. The funny part is when you get together the recommendation, it says, although these recommendations are here, small aircraft have operated significantly less than these operations safely for lengths of time, or how they all put it, but these are just guidance, essentially. So they understand that it doesn't go through. An SAE committee that does that, I'm on that board. So that is an unfortunate thing that isn't very clear. We're trying to get that kind of cleaned up. So what is adequate? Well, a test pilot can do that. The pilot operating the aircraft can say this is adequate, this is not. Generally speaking, the OEM will do that when they certify the aircraft. And If there's ever going to be an upgrade after the fact, that's usually an STC that gets put out to show those things. When we are talking about lights and things you want to look at when you're going to go buy lights, quality is always the thing, right? Materials and the construction generally are similar across different OEM brands. The quality of those materials changes. Lenses in this are the most important part. All the electrical energy you're taking to convert into the correct color, the right angle, and everything, still has to go through a lens. So lenses over time have varying degrees of how well they stand up. So generally, most of the OEMs today that make LED lights, especially for light aircraft, use a plastic lens. We're the same. Injection mold ours so they're optically clear instead of doing a vacuum mold, or some people do. A vacuum mold is very difficult. You take a sheet of plastic and have to heat it and mold it around something. Think about taking an 8x10 piece of printer paper and trying to wrap it cleanly around a basketball. You're going to get wrinkles and deformations and things that don't make the light pass through clear. So one of the things you do to protect over time is hard coat. So you already have this plastic. Hard coat is a liquid application that you cure under UV light, but it does two things. It fills all the little voids and smooths everything out. It gives you this hardened protective layer on your lenses. It protects against abrasion, cracking, those type of things. Also protects against UV light. That's the hardest thing on any plastic in the world is sun. You can see the difference in these. If you look at a lens on an aircraft and it's yellow, or if it's cracked and crazed, those don't have a hard coat, or it doesn't have a thick hard coat and the sun comes from it. That's where you start to get moisture inside and all those kind of detrimental things to lights. The design, it's kind of that other thing. The moisture and all those things, it's one of your things. We're in humid, we're in cold, we're in hot, different pressures are changing. You're going to get that air needs to change and exchange inside the light. If you seal a light tight, you better make sure it's hermetically sealed and pressurized the day you build that light. And I can tell you, hermetically sealed and pressurized is code for going to cost a lot of money. So you don't necessarily want that. So the right thing is, how do you let this light breathe? You want to be able to let the air out, but you don't want to let everything else in. And if stuff does get inside, how are you get it out? Now you might go and see a lens that has some moisture underneath it, or something like that. That means it's a very tight installation that air is able to escape. What is okay, and you'll see this, if you go turn that light on, you're going to create heat inside the light. Heat's going to make the air expand. So it's going to push that out of the light. So if you ever see that on your light, you'll turn it on for a little bit. Let it burn itself out, and it should clean that out. If it doesn't, and after it's gotten hot, you go sit down and there's moisture inside, you got a problem. That means you're not getting any air exchange. We generally have a vent on wingtip lights underneath on the bottom side. It's usually a couple paths it's got to get through to get out, so that you can't just get water straight back in. Or on our landing tax lights that are sitting out in heavy spray down on the ground, we generally use vortex material on the back bars. That's our vent. Let the air out and let it destroy. Last one is the serviceability. We have replaceable lenses. Everybody, as good as we are, sometimes kiss the wingtip with the hanger door once in a while. You go, oh. Get a replaceable light or just a lens. Replaceable lenses are great, but there is something to be said about a replaceable lens that doesn't have a hole in the lens you have to use to screw it down. That is another point for moisture and things to get inside. Best is to try to keep that lens integrity intact so that the only interface is through the gasket, which means you have nice density. This is one that's a really big one. As I mentioned, when you install your lights, you have to comply with the ICA and meeting their requirements. There are lens manufacturers or light manufacturers that specifically say you must polish their lenses once or twice a month with an automotive quality wax. If you don't polish them once or twice a month, they're not going to hold up. Those are the ones you see that turning up. Those are the ones you see that go to crack and go. How many of us are polishing our lenses once or twice a month? Nobody is. Nobody is. We don't have those requirements. We say put them on, check them in. Just a picture, all those light up. That's what you want. Our lights, Whelen, AeroLEDs, all of our lights, 5-year warranties, and that goes on parts. If that lens is a problem, and it's the hard coat wasn't good or there's something there, you send it back and get brand new. If it's after the warranty, our lenses are replacement for low-cost parts. You don't have to go through this manufacturing. I think Spruce is selling lenses for $20. So much easier to find services to go through. Some specifics on what we're looking for. We're going to do some replacements. We try to be form, fit, and function for the light. We try to have that geometry that matches, and we try to match where we're at. So this is a direct replacement for an old Grimes position light. This was the position with the strobe. That's position of the strobe. This is forward and rear position of the strobe. Forward and rear position of the strobe. These are all shaped to match all the originals. Now, what's nice about ours, there's nothing underneath. It's just the wires coming out the back, so you don't have a big chunk that's coming in. That helps things. This is also where we buy ourselves some room. So if you have just a position light on your aircraft, you want a position and strobe, all it really is going to take is to add a wire or two out to the wing together. You don't have to do the whole massive change. We cover that on STC, side station or field. But we have those products that you can say, okay, this light is the same light as this light. They're the exact same base. If this is what I have, but I want to add a slider, this just so happens to fit on there. That's by design. Everything is hopefully dropped in replacement. When you remove LED or remove the standard lights and put LEDs in, strobe light or the strobe power supply has to be removed or disconnected. If you take those strobe power supplies and throw 700 volts at the LED, it's not going to work very well. It's done as soon as you do that. So you must remove them, but the wires that go out there, you can repurpose. Generally, a strobe system to an old wing tip will have a power for the position, a power for the strobe, a ground, and then a trigger wire for the strobe. Well, what do we need when we put a new LED in? We need a position power, a strobe power, a ground, and then we have a sync line, which basically talks to each other, so it lets them flash at the same time. You reuse that little trigger wire as your sync line. It's already connected between the two. The only thing you have to do is where those sync line, where those wires would have tied to the power supply, you just want to tie those two wires together. They're not sending power, they're sending just a quick little signal to each other. That's how we get them to match up. So you can remove those old systems, no new wiring to swap to something new. So the LED lights, so sync, just kind of talk about. It's not required. You don't want to use sync. If you want to go buy the light today and say, I want this, but right now I just want to put the position in. Next time it goes to annual, I'll have them hook up the strobe because I don't have it right now. That's fine. We'll put it on the aircraft. We separate the TSOs on those. So this is TSO C30 for the position. It's C96 for the anti-collision. It doesn't require that they both be used. So it makes it future essentially. Yeah, we'll put it like that's no problem. There are some of these things that are out there. You make them. So we have these little bulb replacements. So we have an existing aircraft. We already have everything up there, the bulbs out. I want to put an LED in the place. You can do that. We make a product called Chroma on the Whelen side. It's called Polaris on the AeroLED side. The requirement for these is still the same though. They have to be approved. So we have to go through and do testing to say these are approved. Where that comes into things here, if we're going to put them in assembly that was TSO approved, this came out of the factory with a red or green lens, with the middle section, and then the white on the back. Well, a lot of these kits that people sell with these, they come with a clear lens. So now you're going to replace the clear lens. Well, now change the TSO assembly that originally was there. You violated the original TSO. It's not legal. You can't put this on your car. So that's one thing we always look at. The other thing is, skip those because that makes sense. You can't flash position lights to act as anti-collision during the day. Sure, you absolutely can, because it's not required in the day, right? At night, you cannot flash your position. It must be steady burning. So you cannot put a product in that is a lamp replacement that flashes. at night to be anti-collision. You don't meet the output, you don't meet the angles, and you cannot flash position. It has to be steady burning. Right now in the market, these are only available for wingtips, not the tail. We don't sell one. I don't know anybody else that does, that meets TSO requirements, because the tail, unlike the wingtip coming in 0 to 110 degrees, the tail has to cover 70 plus an additional 70. So you have to have that much output of 140 degrees to cover everything. Nobody's got it. Because position on the side, angle out, the tail has to be chewed out this way. And that ball just not going to do that. So we don't have any, I don't know of any that are TSO. And the biggest thing, cost versus the reliability. You might have a brand new light, but you're putting in a 50-year-old socket. Those sockets, they don't make anymore, by the way. So I think we bought the last time by all the parts that are used for those sockets, and we're done. That's it. So you're going to put a brand new light in to an old socket. That socket's going to fail on you, and you're going to be upset because you're not still there. It's not going to be the LED, it's going to be that socket. We're talking right now for one of these, about $140. One of these bulbs. For the drop-in replacement all-in-one bulb, we're like $225. For $140 on the airplane, no, you don't have to worry about it. 5 years. And if anything happens, you just get one. That's the way to go. Beacons are a little easier. Look at size, look at the voltage. Third thing is, look at the color. But there's two sizes. There's a small and a wide. Sometimes you have these narrow ones and things like that. If you got a barrel, you're going to find that there's one that's a little more unique. But generally speaking, it's one of these two. We have a narrow base, which is about that big around. We have the wide base, which is about that big around. Our products that we have are direct replacements, and we just have an adapter that covers both. Color can be any of the combinations of red, white, or red and white. The rationale behind red and white is a lot of people like to have the red that faces forward so it doesn't hit the back of the top and get so bright with the white going to the back. Doesn't matter which ones you use for class 1, class 2, class 3, which are the fixed wing side of things, they specify red or white. You can do either or any combination. Again, make sure you take the power supply out. You'll avoid the warranty when you hook it up with the system. This is kind of a look with a couple different options of just go exact same light, mounting base, exact same light with an extra mounting base. These can be on the outside of the aircraft or the inside, just depends how their original configuration was, but they're much simpler. Landing taxis. Generally, you'll hear this size. Are you Part 36, Part 46, Part 64? Your T6, you're Part 6. What does that mean? Parabolic reflector. That's where it comes from. That was the old standard with the filament as they went through. They were all the size. The G code, it's in eighths. 36 eighths, 46 eighths, 64 eighths. So Part 64 is exactly 8 inches. I generally use my hand. These 4 fingers, I kind of got to combine them all. These 4 fingers cover the Part 36 size. The Part 46, it takes like the palm of my hand to do. I won't cover Part 64 there. If you look at most light aircraft are Part 36. Some are Part 64. Barrett's Bonanzas usually have a compass split on that. But generally speaking, most everything else is Part 36. We match the geometry, so it's the same. The big change we made. This has this big reflector. Now we have these little optics. They're kind of an internal reflector. Every LED has an individual reflector. It made the light thinner, made the light lighter, and it made it let us take each of those and adjust the light a little bit so we can change the beam. We can adjust the light. So we talk about the beam. There's 2 different types. We want landing or taxi. Landing is a spot. We want a cone to go a long distance. Taxi is wider. Taxi, in most installations, the old parabolic reflectors, was just a very big round output. So we might have a 25-degree wide circle that goes around. The problem with that is everything that's like 10 feet from the runway and up is wasted light. You're not using it anymore. So our newest ones, we actually spread that. I only have two options for the light. I can send it out at high intensity, right? And reduce the intensity and why. So our newest lights, we actually go 15 degrees tall. Our landing lights are about 12 degrees tall, 12 wide. Our taxis are about 15 tall, like 55 wide. I don't need it to go 6 miles, but I want it out 1,000 feet, and I want to light everything at So that's what we meant with these things. And the TIRs let us do that. LEDs are polarity sensitive. Generally, though, a quality low part will have a reverse polarity protection. If you do put it on backwards, you'll find out that it just doesn't turn on. The best thing to do, though, is when you install the light, or when you take the old one off, take a meter, find out which one's positive. Most OEM installations just have 2 white wires, they're not marked. Because the old bulb just needed power to go through it, didn't matter. So we put that polarity protection just to make sure we don't fry any lights. But you just need to check which one, and when you do that, I always end up taking just a piece of black heat shrink, and I put it over the negative one, put it on, so now you have a white and a black. Just makes sense. Makes sense to me. Voltage, generally they match your aircraft. Latest LEDs, we're just doing voltage agnostic. Whether you have a 12 volt or 24 volt, it just works. That makes life a lot easier. Last thing is the light. Standard bulb, normally we're seeing 25 hours. Appreciate that. We're seeing these 10,000 plus to focus in. The real answer is that landing light is going to outlast you. You can put it on your aircraft, keep the old ones in a box when you sell it, take them off the existing one, put it on the next one, put the old bulbs back in. Output, this is kind of the thing. How do I compare how lights are built? So they're not made equal. The lenses are significantly different. The colors are different. How do I know what I need to look for? So Chromatis, we have a color. There is aviation red, there's aviation green, there's aviation white. We have a color spectrum. We have to get a certain portion within. And there is 2 different. There's CFR, that's FAA regulations, and SA, that's TSO regulations. They're actually not the same. So we always try to find our spot somewhere in the middle of those combined ranges. Red, pretty simple. There's a lot of commonality. The red is it's got a very tight band. Green, not so much. Green is a pretty big band, so you're going to see the correct LED color should be a very, we'll call it deep green, but you will see more of a minty, spearmint, bluish green. That still technically falls in the TSO, but it's kind of on the outside edge. But it falls into just the TSO, not the FARs. So we always try to find something that's in the middle of everything. But color is important. Output is the other thing. So we always talk candela. Candela is the only measurement of output that is mentioned at all in the FARs or in the TSO. There's nothing else that's out there. So what are the ones that are out there that we hear differences on? Well, I mentioned effective candela before, which is just what's the average in a flashing light between the start of one cycle and the start of the next. How do you do that? There's only one formula you can use. There's a lot of people, if you have multiple flashes, I can tell you, you're probably not using that formula. Whelen has always been known for common flash, which is 4 flashes of the old xenon strobes. And our new LEDs are a single flash. And it sucks. We hate it. But it's the only way to abide by that formula. We were able to get by before because those old lights have a ramp up and then a ramp down. The new lights are on, on, on. And because of that, we can't get that much power out in that short period of time to meet those numbers. We're close. We're excited. We're going to bring that back out. But it's been killing us for years that we don't have common flash right now. So multiple flashes, probably didn't use the formula that's required. The other word we hear is lumens. Lumens are cool. Lumens are the potential that light has. Lumens matter in a room like this, where we light up a large area. We're going to send the light out everywhere. Lumens are not a measure of intensity. They're potential. So we have this other thing that we hear, which is, oh, this is a 100 watt versus a 75 watt. It's got more power, it's 100 watt than the 75 watt does. Watt is not a lighting output term. Watt's how much power you're using. If you have a 75 watt something and a 100 watt something, if I say, oh, I got 100 watt, it's more powerful. No one uses more power. It's the opposite of what you want to do with that LED. Everybody's starting to get your ground down. So you're going the opposite route. How do these all kind of put together? I think of this as watt we're going to take out. That's a measure of how much power we're putting into something, not the output. So we're going to take watt out of the mix. We don't talk watts. Intensity in candela versus lumens. Lumens is your potential. You go up to your garden hose, turn the spigot on, walk up to the end of the garden hose. There's some amount of water coming out of the end of the garden hose. That's your potential. It's going in different directions and we're all over this. Put your thumb over the end, focus it. That's the candela. That's your focused intensity. I'm taking this volume right now and I've focused it in a specific spot by reducing the angles I'm throwing everything out. I'm concentrating my light and increasing my output. I have only so much light. How I use it is how I determine what our outputs are. This is also another thing. There's no conversion from lumens to candela. So somebody can't say, oh, this is this many lumens, or this is that many lumens, and it's more lumens than somebody else. They don't have. Lumens are irrelevant. So beam versus candela and color. Beam and candela are directly related. As one goes up, then it goes down, vice versa. They kind of go through. So if you took and compared two products that have equal candela, both 100,000 candela, one is a wider beam, the other one of a wider beam is actually putting out more light. The other one is we have the same intensity, but covering a larger area, you're putting out more light. That's a way to measure against each other. Opposite, I have a 55 wide by 15 degree tall beams. I have another one, exact same, 15 to 55. This one is 35,000. This one is 20,000. 35 is more light because you're getting a higher intensity across that same area. The really crazy short version of how we figure out a beam is we take the absolute peak candela and then we go out to where we get to 10% of that beam. So if our peak, our highest number we get in terms of the center of the beam is 100,000. I walk out, how many degrees until it comes down? 10,000. That's the edge of my beam on this side. And I go that side. So it's basically saying 90% of the light on this side, 90% of the light on that side is in that area. That's going to define our beam. It's very difficult with LEDs because the old reflectors just send the light out one direction. So it's really easy. LEDs, because we have all these little reflectors, we can actually, instead of having a curve of lighting up that kind of looks like this, we can have one that looks like this. Look at that. That's where our tax is. That's an example. 15 tall by 55 wide. You don't go super high. You don't need to. You want it to. So that makes it a little funky when you're trying to compare things. But LEDs generally give you a better quality of light than what you get on nice settings. Color. Very, very important one. You got bluish looking ones, you got whitish ones, you got little yellowish ones. What's the difference? Which one's the brightest? Same candela, same brightness. They're all the same, doesn't matter the color. You can do a red one, you can do a green one. Whatever that intensity of candela, that is the intensity, they're equal. Why is there a difference? Why does something seem so much brighter? Blue is very, very hard on your eyes. Blue looks brighter when you look at it. If somebody takes a light out, shines it at you, this looks bright. You think that looks bright? And they're blue and they're coming at you? It's for a reason. Blue hurts your eyes. White and yellow don't hurt your eyes. But what they do is when they light up out into a field or up on the runway signs, those lights are accurate to daylight color. Blue is going to change the way that those things look. So you're not going to see things called color. That could also pull out some contrast in what you want to see. So I always ask myself, how do we say, here's what we're going to do? Buy a light based on what it lights up, how it's what you light up, versus what it looks like when you're looking at it, because you'll never use it that way. So the best thing I would say is when you go in our booth, hang radio, and hang the speed with AeroLEDs, Go up there, stand next to the light. Look at the guys across the aisle. How bad of a slap it is. Turn it on. We call it the photon slap. To do that, miraculously photons that guy goes every time. We go through, but stand next to the how it lights up. That's going to tell you the difference. That's what you want to see. It's also why we publish pictures of our lights. We take a drone and a scissor behind airplanes. We put all the lights on, swap out. So you see what it looks like. Because that's what you really want to see. All right, installation approvals. We can install under TSO. TSO, again, is a validation of the performance of a product, not the installation. The FAA has said, yes, the performance matches these requirements. The installer has to validate the installation. A TSO for TSO swap, how to do that is covered under the advisory circular. And it basically says, when you go through and you're going to do this, you have these list of criteria. This is how you're going to go through and approve this installation. So I'll get to that in just a second as well. STC is the other way to do this. This is saying we're making a change to the aircraft. STC approval actually validates the installation, not the performance. However, if you've installed and got the STC, you can assume that whoever's making that light, in their approval for their STC, they also have to show the FAA all the outputs. Hey, was I here, was I there? And that those outputs have been confirmed. That's on there. STCs are specific to a make and model and a serial number. That's important. Sometimes we get a little skip here and there, which is how we cover under TSO or PMA that's in there. PMA, parts manufacturer approval, that's a verification that the part being verified exactly matches an old part. That's a part replacement. That's a different way we do an approval. And all these you see stamped on the unit when we buy them. The last one is data. This is, here's all my test data. I send this in and I'm confirming to the FAA that all of this is the required outputs, yada, yada, yada. That takes a lot of time, a lot of cost, and a lot of work. Generally, it's only the manufacturer of the light that does that. That's TSO approval or anything like that. Or the aircraft OEM. They say, yes, we approved it, we need to do the TSO, it's your belly output. Now we get the type sheet. So, TSO approved. That again means the performance of the part has been validated. The installation needs to go by the installer to validate that out. So, if you do not have a TSO approval on a product, you have to prove that as an installer, that you've met TSO performance. Well, do you have the data? Do you have all the test data? Probably not. That's going to be really hard to do. So, if you see a product that says, meets all TSO requirements, where's your TSO label? We don't have it, but we meet all requirements. Well, in order to know you met the requirements, you have to test it. That's the expensive part. So, if you know you meet all the outputs, did you test it? Well, no, you did calculations or analysis. So you didn't test it. You have to test it for TSO. Okay, so if you say you need TSO, but you don't have it, generally means you didn't actually test the part. The test is what's needed to be done. That's the expensive portion. TSO is a simple paperwork exercise. Here's our product. Here's all the test reports. Please give us TSO. It's zero cost. Do that. So if you can tell me your part meets all the TSO, but you don't have the TSO, either you're lazy and just didn't do the approval, or you just calculated and you haven't actually tested the parts. So always be aware of that. TSO install, at minimum, requires a logbook entry for service. PMA, simple thing, again, it's a validation that the part is form, fit, function of the previous part, logbook entry to the install. STC, this is to say, again, the part has been verified on installation on the aircraft. We generally are with a big AML, an approved model list of all the different models the lights on. We validated the installation. Again, it doesn't necessarily need to be a TSO for the light, but most of the time it is. And you, as a customer, can assume if you have an STC that the TSO performance was reviewed by the FAA and it can be verified. No matter what, when you do an STC installation, and if your basis of installation is STC, that is a modification of your aircraft. You're no longer on the standard type certificate, you have a supplement type certificate that requires a minor change. That becomes a 337 form, 337 reach. So you're going to get filled out in there. That's how you do STC installation. So the quick and easy with this would be, what am I using that then? Are you using STC for my install? Are you using TSO? Are you using PMA? Generally speaking, most aircraft is a fit-for-fit replacement. If I have a position light and I'm going to replace it with an LED position light, generally that's a TSO or PMA change. It's a logbook entry from whatever things that are done. Not maybe do itself, great, otherwise they're going to do it. You cannot change your own position lights. So if you look, Part 43, it says that you can change your landing lights, you can replace your bulbs, you can troubleshoot and repair wiring. But it doesn't say that you can create new wiring. It doesn't say that you can remove a full part. It does say you can replace bulbs. Well, in a landing light, it's bulb. You'll bulb up, put the LED in, bulb. On a position light, unless you use one of those replacement bulbs, that you can do. Under Part 43, you sign your logbook name, your logbook or your pilot certificate number, date, you sign it, and you say you replace this with this. That's legal. Change out the entire assembly, you can't do that under preventive maintenance. The other thing to keep in mind is we're using STC over a PMA, it's got to be like light. So if you have just a position light, you say, I want to put strobes on here now, well, that's reviewing your STC installation. That's usually the easiest way to go. Our STC installations, our STC specifically says it's replacement of old with any of these part numbers on any of these model aircraft, which allows you to add the strobe and be compliant. So that's where you use the STC especially. Okay, we're going to go to little questions, but here's the things if you're going to come talk to us, or you're going to call us, or send us an email. Here, we're in Hangar A, is the block kind of location of the screws hangar. Hangar C, just inside the corner. You won't miss Hangar A, because we're right there with the sign and everything. Hangar C, in to the right, is AeroLEDs. And then out in the flight line, just under the tail of the tanker, is our big semi-hospitality center and everything. I'm out there, we've got lights up there too. Any of those places, come ask us questions. Our resellers know a lot of these. But you got something you need, or you want some help, you're not sure what to do. Here's the list of things I suggest. Pictures of the lights. Every aircraft comes out, and you get all these things. Well, I have a 1974 Beach Bear, and it's blue. Perfect. I can get most of the way there. The problem is, and we're working really hard on this, unlike going to Napa or O'Reilly or AutoZone, where you say, okay, I've got a 2000 GMC Sierra, and you can figure out what parts go on the vehicle. I can guarantee that most of your aircraft are not the original equipment parts. Something has been modified, something's been changed. There's an STC that's there for replacement wings, and you've got something like that. So pictures always are worth their weight. Know your make and model, your serial number, and your voltage. Generally speaking, we know when the cutoffs work with OEMs, especially at EAA. When we come here, we get normally we're here, I got a Baron, I got a 172, I got a 150, I got an Archer, I got a Lance. I got some name I can't pronounce that came out of the old Russian bloc that was a home built. I don't know what the heck it is. So send me a picture, give me a picture, that helps. But know the voltage too, because that's going to make a difference sometimes. Oh yeah, I want pictures of the lights on your aircraft. Give me the part numbers of your old lights. If you've taken it off, you have the part number, I can tell you part for part replacement. Also, give pictures of your lights. You have any STCs? You put osmosis air tanks on, anything like that? You guys want to guess what the next one is? Give me pictures of anything relevant to your lights. Let me see the tail. Is it on the rudder? Is it not on the rudder, it's on the roof? Again, get pictures. We can immediately look at the picture and know exactly what you have. So you bring those to us, we're gonna put this. Okay. Questions? Okay. On a new build? Okay. New build, what paperwork do we need? When we send you the lights, anything that has an approval, so that would be an STC, a PMA, or a TSO, you are going to get a document that is a COC, Certificate of Conformance. That says that that part complies with the drawing for that COC. If you want it to be ridiculously tight with how you maintain everything, you take all that up to take those one. You don't need to. And we're in metal. So normally though, if you're going to do the installation, you don't need to have those with that, especially for lighting. But what you want to do is on the installation, you put install this part number, this date, and put that in the logbook. Then you know you have that in there. That's all you can do. When you get that COC from us, that's to say this part complies with the drawing is a valid certified part. That's to tell you that so you can go install it. You don't have to keep that paperwork with the aircraft. If you want to keep it in logbooks. If it's international, you're going to get to 8130. That's a service tag that says being authorized to ship out of the US, and it does have those. As you can see there. Yep, for experimental, you're going to get that with it. You don't need to keep those logbooks with the install. It's there. When you certify your aircraft, that you get your experimental airworthiness certificate, everything that's on the aircraft that day is now certified on the aircraft. So from now on, anything you change, that's all you need to put in the logbook. If you change out the wingtip lights, put that document, remove part number 123, serial number 456, replace it with serial number, part number 0. That's it. Sir?
Is the TSO for a landing light the exact same as for a taxi light? In other words, can I choose one where I put a taxi light on or a landing light?
It's a good question. There's no TSO for landing the taxi. There's no requirements whatsoever.
Thank you.
You can choose.
Sorry to interrupt.
You can choose no matter what. Do I want a landing? Do I want a taxi? It doesn't matter. It's up to you to buy the aircraft. Assuming Part 91. Okay? 135, 50. Part 91, for whatever's there, it's up to the operator to assure that their light on the aircraft is safe for them to operate at. So if you get in and you go, it's up to you, technically, but on the bottom, a lot of these I said it's up to the installer to verify the installation meets requirements. Generally speaking, the mechanic that's going to do the install, if you're not doing it yourself, it's probably going to have you flight test or ground test. So I'll turn it on. It's bright enough, you're good. Okay. So if I was ever in doubt, I would always defer to a landing. Reason for that, it is the most critical for safety of flight. I want in an emergency, if I'm coming down and I got to land because the engine's out and I got to find a place on the land, I want the landing as far as it's going to get in as much time as I can react. So I will always default to the landing line when I only have one shot. If you have two, yeah, split them up.